loss and name of that loss, your
Yes, sir.
explanation and its formula.
Yes, sir.
Shaneshwar, go ahead.
Heat losses in the boiler
Okay.
or supplied to boiler is not utilized to convert water into steam. Some amount of heat always going in the form of losses
Okay.
from the boiler. Various heat losses occurs in the boiler plant
Okay.
are mentioned below.
Okay. First loss you tell. Heat loss
First,
due to dry.
heat heat loss by dry flue gases.
Okay.
When flue gases leaves chimney, this will carry some amount of heat and it will be act as heat
Loss
losses.
for the heat.
This loss can be calculated by formula.
Okay. Okay. Shaneshwar. Okay.
Q1 is
I
equal
got.
to
You are having a little bit range
mg
problem. Okay. I will tell.
cpg in bracket minus PE.
Okay. Good. 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 You understood and you are concentrating also. That I wanted to check. Okay. Then heat loss by the dry flue gases. When the flue gases leave the chimney, still they carry some amount of heat with them. Means they have not utilized all amount of heat to give to water, and that water get converted into steam. So that is not done, but some amount of heat is remain with them, and they carry that heat. And while leaving chimney also, they are carrying that heat. Means that is loss for us because we are supplying heat supplied. We are considering all mass of fuel, okay, into calorific value. Okay, therefore, it is acting as a loss. And formula is there Q1 mg Cpg in bracket Tg minus Ta. Okay, so mg is mass of dry flue gases per kg of fuel. Cpg specific heat of dry flue gases. Okay, and Tg is temperature of flue gases leaving chimney, and Ta is equal to your ambient temperature or boiler house temperature. Okay, so that day we have covered. Then second heat loss is there. So we know that anybody. Suhas, second heat loss. Can you elaborate? Mm.
Yes, sir.
Mm.
Second loss, heat loss due to conversion of water, that is moisture in the fuel into steam.
Okay.
Moisture is present in the fuel. When fuel burns, this moisture takes heat from the combustion and converted into superheated steam. This loss is
Okay.
calculated by formula Q2 is equal to MW in bracket Hg at 1 atmosphere plus CPS in bracket T sub minus Tsat minus HW. That is
Okay.
Q2 is equal to MW 2676. That is Hg at 1 atmosphere
Okay.
plus CPF T sub minus 100. Tsat is 100 degrees Celsius
Okay.
minus HW.
Very good.
Where
So this is one of the
MW,
uh,
where
MW is equal
MW is
to.
equal to mass of water moisture present per kg of fuel. CPS is equal to mean specific heat of steam at constant pressure. T sub is equal to temperature of superheated steam, and HW is equal to specific enthalpy of moisture at boiler at room temperature, that is HF at boiler room temperature.
Good. Good. So in that case, HW is whatever the boiler room temperature is there at that moisture is present at that temperature, and therefore that room temperature we have to take to calculate this HW. And HW is equal to our steam table. HW is equal to HF at here. HF at here feed water, but that is for calculation of efficiency, etc. For calculating this loss, HW is equal to HF at boiler room temperature. Okay, then MW already was rightly mentioned. MW mass of moisture present per kg of fuel, or okay, then M means MW upon MF. Okay, then CP he mentioned rightly. So next loss, third loss, who will tell? Okay, Rutuja. Rutuja कब से? Are you in lecture? I think I find you. Okay, then okay, she is not. Rakesh brother. Rakesh brother. Rakesh brother, are you attending?
Hello, sir.
Rakesh ji, tell that loss, third
Yes, sir.
number loss. Third number loss.
Sir, I missed it on last lecture.
Okay. Then another person, Kunal. Echo. Kunal is there. Okay, Rishikesh Deshmukh or Gaurav.
Yes, sir.
Ah,
Hello.
correct.
Sir.
Tell that loss number, heat loss due to next heat loss. Rishikesh.
Heat loss by water due to combustion of H2 per kg of fuel.
Ah,
Hydrogen present in the fuel reacts with oxygen during combustion and convert it into water. This water also take heat from the combustion and get converted into superheated steam. This loss is
okay.
can be calculated as Q3 is equal to 9H2 in bracket 2676 plus CPS T in bracket T sub minus 100 minus HW.
Okay, then okay, next loss. He's next loss will tell. Next loss, Gaurav number
Yes, sir.
after lecture. Bhagat sir. Next loss,
Yes, sir.
Gaurav. Um,
Yes, sir. Fourth loss,
uh,
heat loss due to incomplete combustion due to insufficient air supply. Due to insufficient air supply for combustion of carbon monoxide
hmm,
from instead of CO2. The combustion heat of CO less than heat of CO2. This loss can be calculated as Q4 is equal to MCO in bracket combustion heat of CO2 minus combustion heat of CO, where MCO is mass of CO present per kg of fuel.
good. Okay, then last loss is I will now tell. So last loss is there that heat lost due to unburned fuel, and that is we know that here some fuel is still we are making all the provisions, we are taking all the cares that fuel should be burned completely, but still some fuel is remained unburned in the form of ash, and that ash we can collect in the ash pit. So therefore some heat, that ash is carrying the some amount of heat, and that heat cannot be utilized to convert water into steam, and therefore that steam, that heat with ash, okay, is remained is considered as a heat loss, and that heat loss we can calculate by formula Q5 is equal to mf1 into cv1, where mf1 is mass of unburned fuel present per kg of fuel. Okay, so mass of ash divided by total mass of fuel, that is the mf1 upon mf per kg. All the quantity of heat losses we have to calculate per kg of fuel, means all these masses we have to calculate divided by this mf mass of fuel, then we will get per kg of fuel, that we have to understand. And into cv1, cv1 is what? Calorific value of unburned fuel. So this is calorific value of ash or unburned fuel, and that our heat supplied case, it is calorific value of fuel, that fresh fuel we are supplying. And last loss always we have to consider is what? Here last loss is there, it is also called as what? Unaccounted heat lost. Okay, then who will tell something about unaccounted heat loss? So who will tell, who will take initiative? I will not tell name, but at your own initiative. ही चुकून माझं झालं बोलले. Who will tell? Who will take initiative without taking my name? Somebody can tell. Okay. Nobody is there. Nobody taking initiative. So regular students I know, but others. Prathamesh Patil, Rahul Chaudhary, Prathamesh Patil, Rahul, Prathamesh. Okay. So then Suhas, Kunal, Shubham Singhan. Shubham is there.
Yes, sir.
Shubham. Ah. Okay. Shubham. Okay. Let Suhas Shubham. Shubham will give chance. Shubham. Shubham
Yes,
Singhan.
sir.
Shubham.
Yes,
After
sir.
lot time I am hearing your noise. Voice.
Heat lost
Shubham.
due to radiation.
Hmm.
Heat lost due to radiation or unaccounted heat loss.
Good.
It is also called as unaccounted heat loss. Many boiler parts are exposed to atmosphere. The surface of boiler radiates energy in the form of heat loss to the atmosphere. There is no specific formula to calculate heat loss due to radiation, hence it
Okay.
is termed as
Yes.
unaccounted heat loss.
Okay. And how to calculate it? By heat balance. Q6 is
Q6
equal
is
to
equal
Q. Okay.
Qs minus Q plus summation of all remaining losses.
Good. Good. Where QS is heat supplied to the boiler and Q is heat utilized to convert water into steam. That is our main aim. And plus summation of all remaining losses. So what are the remaining losses? They will give in the numerical that all remaining losses that means we have to calculate their heat by formulae and that plus heat utilized to convert water into steam. That addition we have to subtract from heat supplied. Whatever is remained unaccounted, that is called as heat loss due to radiation or unaccounted heat loss. Okay. Then last time I think we have also started the heat balance sheet of a boiler. Okay. Now Swas, you take lead. What is heat balance sheet? We have discussed on that day. Swas.
Heat balance sheet, it is the performance sheet of a boiler in a tabular format. It gives information about the total heat supplied to the boiler at various ways by which heat is utilized from the boiler. It always indicates the efficiency of boiler and different heat losses in the boiler plant.
Okay. So heat.
From the heat,
Okay. Continue. Continue. Continue.
from
Continue,
the heat
Swas.
balance sheet, an engineer can get corrective measures for increasing the performance of a boiler. Generally, heat balance sheet of a boiler is drawn on 1 kg of fuel basis.
Okay. And that where layout also have started. Correct, na? The heat balance
Yes, sir.
sheet of 1 kg of basis layout. In that two tables we have written, correct? Na? Table we have drawn, I have drawn, or only I have drawn.
Yes, sir. Drawn, sir,
Students,
drawn.
student drawn. Okay. So heat balance sheet is nothing but a performance sheet of a boiler. So it gives what we can call it is a performance of a boiler. Means it can give the efficiency of that boiler. Okay. Then it can give the amount of heat losses and percentage of that heat losses, how much amount of heat is supplied and how much heat is going in the form of that loss that we are getting. So if one can get that in the one particular area, if more amount of heat is going on, going waste, then and if that engineer or that particular that management has done some good work project and they minimize that particular heat loss, then drastically it will increase the efficiency of that boiler or it whatever they will save that during that loss, that amount will be added in the efficiency. So efficiency will be increased by saving the losses or minimizing the losses. So if losses get minimized, whatever the saved quantity is there, it will obviously it will increase the efficiency of boiler. Then this heat balance sheet generally we have to draw per kg of fuel basis. So first sentence is there. That is heat balance sheet we have to draw on 1 kg of fuel basis or coal basis. Okay, and it consisting of three columns. Okay. Now who will tell three columns? Okay. Already it is there, but some from anybody, three columns it is having. One is anybody heat supplied, then heat utilized from boiler, and third one is percentage utilization. Everybody got this message reply? Heat supplied, you written heat supplied, heat utilized, and from boiler and percentage utilization. Okay. So only one reply I got, that is from Swas only. Others are not understanding. This means this indicates that others are not attending lecture sincerely or they are not understanding. Reply. Okay, two. Second message I got. Okay, okay. Now I am getting good. So Pramod, Shubham. Okay. So this is heat supplied kilojoule per kg. It utilized from boiler. It okay kilojoule per kg. And next is what? Percentage utilization. Okay. Then here heat supplied, we are supplying that particular heat by only one means. That is Qs is equal to mf. It is m only, here consider mf into calorific value. But we are drawing the heat balance sheet on only 1 kg of basis. Therefore mf will become 1. So consider it as mf. Therefore Qs is equal to mf into Cv, 1 into Cv, it will become Cv. Okay. Then first, what are the purpose of boiler is there? What is the purpose of boiler? That water we have to convert into steam. Okay. So means water should take the heat from that particular combustion of the fuel, and its enthalpy should get increased, and accordingly it should get converted into steam. So for, as we are drawing the heat balance sheet on here, right side column, heat utilized column, on 1 kg of basis, all the masses, ms, mass of steam, mass of dry flue gases, we have to take per kg of fuel. And for that, as we have taken one here to get the quantity of masses per kg, we have to divide each and every mass in the heat utilized column by mf. That we have to take care. So here we have to take care that all the masses in the utilized column should be divided by mf, mass of fuel. Okay. Then first utilization is there, heat utilized to convert water into steam, and that will be q. We are noting by this letter by q. Q is equal to s into bracket hs minus hw divided by mf. So first of all, ms into bracket hs minus hw divided by mf. Okay. And where hs is equal to enthalpy of steam, hw is equal to enthalpy of feed water. Here we have to take feed water at feed water at here whatever the feed water is available at what temperature of feed water. So hw is equal to hf at given feed water temperature. Okay. So q is equal to ms upon mf into bracket hs minus hw, and here in this case percentage utilization, q divided by qs into 100. Q divided by qs into 100. Okay. Then second, or here ms upon me, here we can also write as a ms. This I think we have written in your notebook. Everybody written this first loss, sorry, first utilization, first column I think we have completed.
Yes, sir. First column written.
Okay. Sorry, first row, not column, first row, correct na? Okay. So as second we have written, second, is that?
No, second
Okay.
not written.
Okay, okay. So is q is equal to me, ms upon me is equal to me into bracket hs minus hw, and percent utilization will be q1, q divided by qs into 100. Now if you go in detail, q means what? Me into bracket hs minus hw, okay, divided by heat supplied, okay, that is cv. What this formula indicates? Anybody? What this formula indicates? 100 divided by. Okay. So on that day, we have completed this. Okay. So what is this? Here first utilization is there. That is what we are getting. So first percent utilization is equal to the first utilization is there. What? So first utilization is there. That what is there is equal to first utilization is there. What is that utilization? Q divided by QS into 100. But if you see what is Q there, so Q is equal to what? MS upon MF, okay, into bracket HS minus HW, okay, and QS is equal to, what is QS is equal to, divided by, I will write here, QS is equal to, or here, okay, into 1 upon, QS means what? Calorific value only, okay. So this we are calling it as a ME into bracket HS minus HW divided by calorific value. What is this formula? Anybody? Anybody can reply. What is this formula is there? First utilization. The first percentage utilization first. Anybody? What is this formula is?
Efficiency of boiler.
Correct. It is what? Efficiency means what? First utilization is always gives the value of what? Here efficiency of boiler. So it is the first utilization is always nothing but what? It is a eta boiler. So we have to take that here eta boiler should be as maximum as possible, because efficiency should be always we want. Efficiency should be always as more as possible. So it is a eta boiler. Everybody understand? So first utilization should be here eta boiler. So this is a nothing but what? Here efficiency of boiler. Okay. Now second utilization is there. Now we will consider the losses. Second we will consider it as what? We will consider one by one losses. Then what is the loss? First loss we will consider. Write down in your equation. Or shall I go to notebook directly now? You will understand, na? So here second utilization we can go for as a losses will start. So first we know. Then second is write down. Heat carried away. Are you writing? All of you are writing. Second now. Heat supplied is now only one. Here it is only to go for total. So don't worry. Here it is will be heat carried away by dry flue gases. Heat carried away by dry flue gases. Heat carried away by dry flue gases. Then what is Q1 is equal to, what is formula? mg into cpg into bracket tg minus ta, into bracket what? Tg minus ta. But mg we are taking it as what? Per kg of fuel. Therefore we can consider all masses should be divided by mf. So mg upon mf into cpg into bracket tg minus ta. This is the loss. There that way also heat will be utilized in the form of loss, and here it is be effectively utilized for conversion of water into steam. And here it will be Q1 divided by means, and percent utilization is Q1 divided by QS into 100. So it will be loss. It will be efficiency. Anybody have written second loss? Heat carried away by dry flue gases in heat balance sheet. So many times they are asking the question that explain the heat balance sheet with its proper layout. So this layout we have to draw at that time. Everybody on written, so that if you are writing, giving your feedback, yes, 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 then I will go to proceed to next point. Maximum should write, so that I will get that you are writing. Okay, good. Saurabh Pawar, good, good, good. So it is what second thing we have written. Now another losses are two main losses are there, but we are drawing heat balance sheet on the samples form, sample case. Therefore, what we'll do here, only few important losses or simple losses will take for our sample heat balance sheet. And in the numerical, whatever the information about loss they have given, that loss only we have to consider. But this is EMF, heat supplied, this sequence is good, we have to consider. Then afterwards, heat utilizer we have to go for. And then afterwards, if it is a heat carried away by dry flue gases, generally they will mention the dry flue gases, because dry flue gases is the major heat loss occurs in the boiler plant. So maximum where the heat loss is going in the boiler plant, it is losing from the in the boiler in the form of only heat carried away by dry flue gases. In second, third loss, as a sample basis we are trying, therefore only 3 to 4 loss we will consider. Simple that way. Then heat loss due to unburnt fuel. Heat loss due to unburnt fuel. Third heat loss. So though it is a sequence is not there, but here we will consider only simple. Therefore, heat loss due to unburnt fuel. Here we have to maintain sequence Q2. There it may be Q4 or Q5, but here we have to maintain here, as we are writing here only some Q losses. Its sequence only Q1 to then afterwards Q2. Heat loss due to unburnt fuel. What is formula? MF1 into CV1. MF1 into CV1. But here in this case, MF should be, it should be divided. MF1 should be divided by MF. Why? Because we want the mass of unburned fuel per kg of fuel. We want that mass of unburned fuel per kg of fuel. Therefore, MF1 should be always divided by MF, and it should be multiplied by CV1, because that fuel, when it is remain unburned, it is having some calorific value. Means that calorific value, that heat is not utilized by that by water to convert it into steam. So Q2 is equal to MF1 divided by MF into CV1. Have written loss number 3 also, here 2. Loss number 2 written. Yes, if you mention fast F, and its utilization will be definitely, its percent utilization formula will be remain same. Q2 divided by QS into 100. Okay. Then, good. So everybody is writing, no problem. Then always we have to consider the last loss, though they will give information or not give, because it can be only calculated by heat balance. So QS minus in bracket Q plus summation of all remaining losses, it will give the equation for formula for this Q3, heat loss due to, now write down, heat loss due to radiation, and Q3 is equal to heat loss due to radiation. Q3 is equal to QS, heat supplied, QS minus in bracket Q3 is equal to QS in bracket Q means what is heat utilized to convert water into steam, okay, plus summation of all the remaining losses, remaining losses. So Q1, Q2 only. So here it will be Q3 is equal to QS minus in bracket Q plus Q1 plus Q2. And when it will get the value, its utilization we can calculate by formula. What is the formula? Q3 upon QS, it's applied into 100. Q3 upon QS into 100. Okay, have written heat loss due to radiation. Okay, so heat loss due to radiation, Q3 is equal to QS minus Q plus Q1 plus Q2, and Q3 upon QS is into 100. Have written. heat loss due to radiation. Then here we are getting total, like this you write down QS, total column is there, total. Okay, so you write like this. So total where I am pointing, pointer is there outside that, like here you make it a total or a total. This total you shift to this side. This total you shift to this side. Okay. Total QS is equal to calorific value because it is called. And here total will be, what is total here? What is total here? Is equal to what? First weight and center is Q plus Q1 plus Q2 plus Q3. Okay, Q1 plus Q2 plus Q3. Okay, and here percentage utilization, what will be addition will come of all percentage? Anybody? Percentage of all addition, percentage, when we consider the percentage, if you add all the percentage, everything will come into equal to, anybody?
100%.
Okay, 100% is what? 100. Now 100. Now here in calculation, though your answer is coming as 99.98, what we should write? Because we should write always 100. Though you are getting 99.98, but still we have to write it as a 100 because it is a heat balance sheet. So all the heat percent utilization should equal to 100. This is the balance. Everything is get balanced. Therefore, we should not write 99.98. You should write always 100. But don't write, if you say here your percent utilization is coming as 67, 70, and Gaudi sir told that we should write 100. Then don't write. Only in case of the answers, those are near to 99.98, 99.96, 7, near about answer 99.98, 99, you should write it as 100. Otherwise, we have to consider that if answer is coming 67 is coming addition, then we have to tell that our some calculation get wrong. And here also, whatever the heat supplied is there here. So if it is the heat supplied is coming as what? 26,000 only. It can drop value 26,000. And here also, if answer is coming as 25,999.7767, then also we have to write it as a, instead of that we have to write it as a here 26,000. Don't write exact value. You should be what? 26,000. But again I am telling that, what I am telling here, if answer is coming as 26,000 is the calorific value and your addition is coming as Q plus Q1 plus Q2 plus Q3 as a 20,000 something. Okay, then don't write 26,000. Then we have to in here tell yourself that somewhere I have made that kind of mistake. Okay, so if answer is nearer to 25,000, so you should write it as, because it is a heat balance sheet, like our audit statement. जेवढे पैसे येतात, आपलं ऑडिट असतात का, आपलं जेवढे इनकमिंग आणि आउटगोईंगचं ऑडिट असतं, म्हणजे जमा झालेले आणि खर्च झालेले, जेवढे जमा झाले तेवढेच आपल्याला काय करावं लागतात, खर्च करावं लागतात. आणि थोडा गॅप असतो त्याला आपण अनअकाउंटेड म्हणतोय. त्यामुळे पण ऍडिशन मध्ये आपण अनअकाउंटेड धरलेलं आहे. सगळ्यांची बेरीज, इथली जी बेरीज येते, इथली बेरीज आणि इथली बेरीज एक्झॅक्ट सारखी पाहिजे, आणि इथली पण इथं 100च पाहिजे. दॅट केअर वाय टू टेक. एव्हरीबडी अंडरस्टँड दिस हीट बॅलन्स शीट? Everyone understand this sheet balance sheet?
Yes, sir.
Okay.
Yes, sir.
Okay. Now here, I think we have completed. So here you write down total. Okay. And here you also make it a total Q1 equal. And these should be equal to same. Okay. But here if too much difference is there, you have to tell yourself that calculation may get wrong and we have to do the recalculations. And here always this summation should always be exact 100. Though in the calculator calculations is coming as 99.9998, we try it as a 100. And if it is too much away from 99.98, say 90 to 93, then we have to consider that our answer is our calculation gets some wrong. Okay, now everybody understand this completes theory of our performance of boiler. We have invested more lectures because were not aware about the boiler. So starting from boiler study, classification, then different kind of sub boiler, okay, that Cochran, Babcock and Wilcox. So we have taken the numericals. Now we are at the end of this chapter. If two numericals will take, one or two or three, just today, if may possible, two numerical we can complete. Okay, shall we go to numerical now? With your permission, if you tell yes, 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 then I will proceed for the
Yes,
numerical.
sir.
Okay, write down now. So, first numerical is there, write down. In a boiler trial, in a boiler trial, following observations are obtained. In a boiler trial, following observations are obtained. Write down. Mass of feed water. Mass of feed water is equal to 1520 kg per hour. आता हे एक लक्षात ठेवा, हे एक महत्वाचं असतं. कधी कधी काय करतात, मास ऑफ स्टीम देण्यापेक्षा काय करतात, मास ऑफ फीड वॉटर देतात. पण जेवढं आपण फीड वॉटर बॉयलर मध्ये सप्लाय करणार आहे तेवढं सगळं फीड वॉटर काय होणार आहे, कन्वर्ट इन टू स्टीम. कारण फीड वॉटरला कुठं आपण इकडे तिकडे लॉस, कारण ते बॉयलर आपला क्लोज्ड वेसला आहे. जेवढं फीड वॉटर आपण सप्लाय करू तेवढ्या मध्ये हीट जर आपण सफिशियंट अमाऊंट ऑफ कंबशन हीट जर प्रोड्यूस केली तर तेवढं सगळं फीड वॉटर काय होते आपल्याला कन्वर्ट इन टू व्हॉट, स्टीम. तिथे लॉस आपण कन्सिडर करत नाही. त्यामुळे मास ऑफ फीड वॉटर इज ऑलवेज इक्वल टू मास ऑफ स्टीम इव्हॅपोरेटेड फ्रॉम द बॉयलर. ते लक्षात ठेवा. म्हणजे कधी कधी मास ऑफ स्टीम देण्यापेक्षा मास ऑफ फीड वॉटर देतात. म्हणून ही काय आहे, कुठली क्वांटिटी दिली आहे, MS. ओके. देन टेम्परेचर ऑफ फीड वॉटर. टेम्परेचर ऑफ फीड वॉटर. Okay, so next in boiler trial following observations are obtained. Mass of feed water 1520 kg per hour MS. Then temperature of feed water, 30 degrees Celsius. Temperature of feed water 30 degrees Celsius. Third, dryness fraction of steam. Whatever steam is coming from that boiler with this quantity of mass and temperature of feed water, dryness fraction of steam whatever coming out from boiler is 0.95. Means X is equal to X. Means what is given? X is given. Then pressure of steam. 8.5 bar absolute. Pressure of steam 8.5 bar absolute. Pressure of the steam also they have given. Then coal burn per hour. Here both quantity should be per hour. This is our here. This quantity should be also per hour, mass of feed water, and coal burn also should be per hour. Because instead of that here giving here, they have given in sentence that coal burn per hour is equal to 200 kg. Okay. Then CV of coal, calorific value of coal. Calorific value of coal 27,300 kilojoule per kg. 27,300 kilojoule per kg. 27,300 kilojoule per kg. then ash and unburned coal collected. Ash and unburned coal collected. Ash and unburned coal collected. 16 kg per hour. 16 kg per hour. Then CV of ash and unburned coal. Here don't write burnt coal, unburned coal. CV of ash and unburned coal is equal to 3780 kilojoule per kg. 3780 kilojoule per kg. Then mass of flue gases. Mass of flue gases. Mass of flue gases. 17.3 kg per kg of fuel. What is they have given? Anybody? Mass of flue gas is equal to 17.3 kg per kg of fuel. Anybody? What is given this? So directly they have given here value of mg upon mf. So directly they have given the value of what? Mg upon mf. Okay. So 17.3 kg means mg upon mf is equal to 17.3 kg per kg of fuel. Then temperature of flue gases. Temperature of flue gases 330 degrees Celsius. Temperature of flue gases 330 degrees Celsius. Then boiler room temperature 17 degrees Celsius. 17 degrees Celsius. Okay. Then mean specific heat of flue gases. Mean specific heat of flue gases 1 kilojoule per kg Kelvin. Mean specific heat of flue gases 1 kilojoule per kg Kelvin. Then determine thermal efficiency of boiler. Determine thermal efficiency of boiler and draw heat balance sheet on 1 kg of coal basis. What is they asked? Determine thermal efficiency of a boiler and draw heat balance sheet on 1 kg of coal basis. So earlier these numericals were asking for 7 marks, but now I think it may be for 5 to 6 marks. Therefore calculations, the easy, whatever the easy losses are there, they will only give in the numericals. Okay, and then here it is asked for May 2013, December 2009. Okay, so this numerical is asked for 1 or 2 times in the examinations. Everybody written numerical systematically. If yes, we will proceed for the calculations. If yes, or everybody is sleeping. Everybody have written the numerical systematically. Okay. So Shaneshwar, okay. Shaneshwar is giving response. Okay. Suhas now. Okay. Subham Shingan. 3 only replied. Others have written numerical. Okay. Okay, good. Saurav, Prathamesh. Okay. So others also reply. Okay. Rahul Chaudhary. Good. Balaji Pise. Good. Okay. Now we'll see. Now directly we'll draw the heat balance sheet. You have to help me in this case. So instead of drawing here everything, so we'll draw heat balance sheet here only. Okay. Now here some calculation part will some space I will reserve. So here it will be heat supplied. Give heading here only kilojoule per kg unit and heading here only kilojoule per kg, and this will be okay. And then heat utilized, heat utilized. Okay, here it will be here also kilojoule per kg. So at this space I am utilizing for my calculation, and here we can go for percentage utilization. So draw with this means, in some space you can percentage utilization. Okay, so this is written. So percentage utilization. Sir, sorry for disturbance. Meet is consuming much data. 500 per hours. Please change video quality settings. Okay, Gaurav. But now I think Gaurav.
Yes, sir.
Next lecture I will take care. You tell me advance. Now I think if I will change the setting, I may you or some problem may happen. Henceforth will take care. Gaurav. Gaurav.
Yes, sir.
What I had to go for Gaurav? Setting
तर
means
सेटिंग मध्ये ऑप्शन येते हाय क्वालिटी
बर
म्हणून
मग
मग
त्यात
लो मीडियम हाय म्हणून
लो करू का मग ते
हा
आता
सर
हाय
मला पण माहित नाही पण लय वेळेस बघितलं की मी म्हणजे लेक्चर वगैरे घेताना सरांनी लो क्वालिटी केली.
बर ठीक आहे मीडियम क्वालिटी आपण ठेवूया हा ओके ना ओके
येस सर.
ओके नाव हिअर heat supplied heat utilized kilojoule per kg and percentage utilization. Okay, percentage utilization. Okay, then heat supplied. Now heat supplied is what? QS is equal to, we'll tell formula. We'll tell formula of QS is equal to, somebody can add your own, you can tell. QS equal to
CV.
means CV means MF into CV, but MF we are considering it as a
1.
1, therefore it will be equal to, write down here also in your notebook also, 1 into CV. Make that kind of practice. And what is CV value now? Anybody? Now that you have to tell me value. Those are now referring numerical. Kilojoule per kg, what is value, MF value? So that numerical is not there in front of me now. I'm came in PowerPoint presentation box. Okay, who will tell? So ask.
27,300.
So it is what? 27,300 kilojoule per kg. So heat supplied, there is no problem. Have written, everybody written?
Yes, sir.
Okay. Now here, utilization, first column of utilization. What is first column of utilization? First column of utilization. What is we are considering? What is the main purpose of heat boiler?
Heat utilizer to convert water into steam.
Okay. Heat, write down. Heat utilized. Utilized to convert water into steam. What is that value? Q is equal to, what is formula? Anybody? Q is equal to, Q is equal to ms divided by mf into what? hs. Anybody? Minus hw. Okay, and is equal to what? We have to solve. Therefore, Q is equal to, right? Now this calculation of Q I will write. You also write here Q is equal to. So here sufficient. Okay. So Q is equal to ms. Who will tell value of ms? ms. So write down here. Here you can write the only formula and answer, and here you do the rough calculations outside. What is the value of? What is the value of Q? ms, sorry, ms. Mass of steam
1520.
1520. So write down this calculation 1520. Outside table if into can calculate it will be better. 1520 divided by mf. How much amount of fuel we have burned? The same time kg per hour.
200.
How much fuel we have burned? Huh?
200.
How much fuel we have burned? How much?
200.
200. So okay, 200. Okay. Now value of HS we have to calculate. How to calculate this HS? To calculate this HS, what do we have to go for? HS is what? Steam is what? Steam is, anybody? HS means what? Steam is
Wet steam.
weight. Therefore, HS is what? As steam is weight, write down in here. HS is equal to steam is weight here. Therefore, HS is equal to, what is the value of HS? Here. Who will tell? Weight, steam, enthalpy. How we can calculate? Anybody? Other than Suhas? How, what is the HS is steam weight, steam is weight, okay, and HS is equal to weight steam enthalpy. Saurabh Pawar, how to calculate weight steam enthalpy of weight steam? Suhas सांगा तुम्ही दादा. HF
HF plus XHFG.
XHFG. HF plus XHFG. And Gaurav. Okay. HF and HFG. To record HF and HFG. Okay. To record HF and HFG. What do I have to go for? HF and HFG recording. What is given now? Gaurav, are you in lecture?
Yes, sir.
What is given? HF and HFG. To record HF and HFG, what do I have to go for? What is given?
Sir, मी numerical लिहून घेतलं, मी disconnect झालो.
Okay. So it is what is given? Pressure is given. And from that pressure, we can use our steam table and we can take the value of HF and HFG. So HF and HFG, what at what pressure they have given value of pressure value? Anybody? HF and HFG?
8.5 bar.
8.5 bar. So pressure is given as what? 8.5 bar. 8.5 bar. At that pressure, we have to go for HF and HFG. We have to record. Then, which table number we have to refer now? Table number?
Second.
ठीक आहे ते असेल की माझ्याकडे पटत तुम्हाला 3 वाजता लेक्चर. Okay, HF plus XHFG 8.5 bar. Okay, and HF and HFG we have to record 8.5 bar. Then steam table. Which table number I have to go for? Steam table. Which table I have to go for? Steam table. Which table number I have to go for? Anybody?
Table number 2, sir.
Table number 2. So table number 2. Shall I go for direct now? Table number 2. Okay, so table number 2 I have to go for. Okay. Table number 2. Okay, Shanesha, okay. Also table number 2 directly I will go to table number 2 where pressures are given. Now table number 2 means what? When pressure of steam is given, we can record the other data. HF, HFG, SF, SFG. So that kind of practice we have done. Table number 2. And pressure is, how much pressure here? 8.5 bar. Pressure is 8.5 bar. Okay. So 8.5 bar, whether it's available, not available. But what is available? 8.4 and 8.6. Its mean, its average will be 8.5. So HF and HFG. Okay. So 8.5 bar. So 8.4 and 8.6 average घ्यायचा 8.5 ला. HF म्हणजे काय येणार? HF ची व्हॅल्यू किती येणार? 729.9 आणि 734.2 यांचं मीन. आणि HFG कुठली आहे? इथली 2039.6 आणि 2036.2 यांची बेरीज करून ॲव्हरेज काढायचा. ह्या दोनचा कॉज 8.5 इज ॲव्हरेज. ओके. देन विल टेल नाऊ म्हणजे ॲक्च्युअली किती येणार उत्तर? 739 म्हणजे 732 किंवा येईल आणि 237 38. ओके. तर आता तुम्ही मला सांगा कोण येतं. ओके. सो कोण सांगते? HF ॲट 8.5 बार 700 किती येते? एनीबडी? 732 HF. ओके. शुभम सिग्नल 732.5. 732.05 आणि एक्स किती दिलाय? ट्रान्सफॅक्शन गिवन. एनीबडी? 0.95 0.95 इंटू ओके HFG. हां HFG किती आहे व्हॅल्यू? एनीबडी? HFG प्रथमेश पाटील. HS काढली 2667 पण HFG आपल्याला लिहायला किती?
2037.8.
आणि टोटल HS किती आला? 20
HFG ची व्हॅल्यू.
हां 20
HFG ची व्हॅल्यू
HFG 20
37.8.
2037.8. You consider it as 8 and total HS is coming as what? 2667.9. 267 kilojoule per kg. Okay, 2667.9 kilojoule per kg according to Prathamesh Patil. Okay, Prathamesh, all are getting same answer. Everybody understanding? Okay, HS is equal to 2667.9 kilojoule per kg. Then also we have to find out value of HW. What is HW value? HW is equal to anybody? HF at feed water temperature. So I'll write it is T feed water. Feed water. Temperature of feed water. Then what is feed water temperature? Table number 1 we have to go for. What is feed water temperature given? HW is equal to HF at T feed water, and HW is equal to HF at what? What is feed water temperature is given? Anybody?
30 degrees Celsius.
30 degrees.
Okay.
Okay. So table number 1 we have to go for. Steam table number 1. Okay. Steam table number 1. Steam table number 1. Pressure, now temperature is given because pressure is not given. Temperature is given in table number 1. And temperature is how much? 30 degrees Celsius. And 30 is available. Good, it is available. 30 degrees Celsius, what do I have to see? HF value. So HF is there and 30. What is value? 125.7. Okay. So HF is equal to what? HF 125.7. 125.7. Again it is what? Kilojoule per kg. Kilojoule per kg. Everybody got this? MS we got now 1520, MF is 200, HS we got, and HW we got. So Q is equal to, what we are getting, Q is equal to here HS. How much? 2667, 2667.9. प्रथमेश बरोबर आहे का हो?
Yes, sir.
बरोबर आहे. ओके. Others are also getting. कोणाला ऑब्जेक्शन नाही ना? तो म्हणजे सगळ्यांना बरोबर आहे ना? व्हॅल्यू बरोबर वाटतं सगळ्याला? सगळ्यांचं आलं का व्हॅल्यू एवढंच? 2667.9. ओके. आणि मायनस किती आहे तुमची? ऑलरेडी वॉटरची एन्थॅल्पी तिथनं वजा करावं लागणार आपल्याला. 125.7. म्हणजे हीट युटिलाइज किती आली? क्यू किती आली आपली व्हॅल्यू? क्यू इज इक्वल टू हीट युटिलाइज्ड कन्वर्ट वॉटर इंटू स्टीम. किती येते? एनीबडी? 1520 डिवाइड बाय 200 into 2667.9 minus 125.7. कोण सांगते? गौरव वगैरे करा कॅल्क्युलेशन. गर्ल साइड ऋतुजा कापसे and other are attending lecture, are doing calculations. Any representative from girl side? Okay. Then who will tell? Prathamesh Patil, Gaurav, Shubham Shingan, Ajit Gaikwad. Kunal today Kunal is absent. Okay, Suhas. Doing or only I am. What is this calculation? Okay, so somebody has written, I think, calculation. So 1900 320. 1900 320. Okay, so somebody has given answer. 1900 320. Shall I write? Shubham Shingan got answer. So it is what? 1900 320. 0.72 kilojoule per kg. So as I have given that unit will be kilojoule per kg. Already here we are giving the unit, therefore here it will be what? 1932 0.72 kilojoule per kg. Okay, 19320.72 kilojoule per kg. And this utilization is nothing but ETA boiler. What is that utilization? Q divided by QS Q divided by QS into 100. And what is that percent utilization is coming as? Anybody? 70.70 or 70.77. And this is acting as what? There is no need to calculate separately efficiency. Here only we should write it as a afterwards in answer. After drawing this heat balance sheet, we can consider this as a ETA boiler. So 70.77 is the efficiency of boiler coming. So first answer we got. Everybody understand? Everybody understand? Suhas only thing. Gaurav, okay. Gaurav, Suhas, okay. Good. Then ETA 70.77. Now second utilization. What information of which loss they have given? Who will tell? Which information? Which loss information they have given? Anybody? Heat carried away by dry flue gases. Correct na? So dry flue gas information they have given. Heat of heat lost or by dry flue gases. Heat loss due to dry flue gases. Loss due to dry flue gases. What is formula here? Q1 is equal to mg इकडचं सगळे पर केजी असल्यामुळं mg अपॉन mf into cpg into bracket tg minus ta. Okay, and directly here I will give answer. Now shall I go to next slide? Now Q2 I am calculating here. So Q2 is equal to mg upon mf into cpg into bracket tg minus ta. Now mg upon mf will tell the value. फास्ट आपले 15 मिनिटांची आपल्यावर mg upon mf ची व्हॅल्यू किती दिलेली आहे? एनीबडी? mg upon mf व्हॅल्यू किती दिली?
17.3.
सगळे टोटल व्हॅल्यू दिली का फक्त mg ची दिली? mg upon mf total they have given it as a 17.3 because per kg of fuel they have given, therefore per kg of fuel 17.3 flue gases are coming out from the boiler. Okay, 17.3 into cpg किती व्हॅल्यू आहे cpg ची? Anybody? 1. Okay, into tg minus ta. आता डिफरन्स असल्यामुळे दोन्ही टेम्परेचर सेल्सिअस मध्ये असले तरी चालते आणि केल्विन मध्ये असले तरी चालते. फक्त डिफरन्स असल्यामुळे दोघांचं फक्त युनिट एकच पाहिजे. ओके, तर आपला आता किती आहे टीजी किती आहे आपली टीजी व्हॅल्यू
330 डिग्री सेल्सिअस.
330. ओके. आता इथलं आपलं सीपीजी किलो जूल मध्ये असल्यामुळं सगळे आन्सर आपल्याला कशामध्ये मिळणार किलो जूल मध्ये मिळणार. सीपीजी 1 किलो जूल पर केजी केल्विन करेक्ट ना. आणि मायनस टीए बॉयलर रूम टेम्परेचर किती आहे टीए बॉयलर रूम टेम्परेचर टीए
17 डिग्री सेल्सिअस.
17 डिग्री सेल्सिअस. आणि ह्याचा आन्सर किती येते व्हॉट इज आन्सर इज कमिंग एनीबडी
5414.9.
5414.9
9.
unit is kilojoule per kg. Everybody got this 5015 kilojoule per kg. So Q2 is equal to mg upon mf already they have given because utilized column we are drawing we are taking all masses per kg of fuel. Therefore mg upon mf into cpg into bracket tg minus ta. Okay, and 5413. Everybody written this okay in our outside table, and now you will take in the table. What is value 5414.9. What is utilization now? Percent utilization is coming as how this loss is, how much loss is in percentage? Q1 upon US into 100. What is percentage? Who will tell percentage? Somebody may have calculated. Okay. Suhas has calculated 19.83%. Already percentage is there, therefore it is not required to write percentage here. 19.83. म्हणजे जवळजवळ 20% हीट आपली हीट लॉस ड्राय फ्लू गॅसेस मधून काय होते वाया जाते. म्हणजे एखाद्या इंजिनियरनं जर ह्याच्यामध्ये जर थोडा कंट्रोल आणला हा जर कमी केला 10% पर्यंत तर 9.63 डायरेक्टली कशामध्ये ऍड होईल बॉयलरच्या इफिशियन्सी मध्ये. म्हणजे हीट बॅलन्स नुसार आपल्याला कळतं की कुठे जास्त हीट वाया जाते. ती हीट जर आपण वापरली तर की इफिशियन्सी कितीने वाढू शकते. ही जी स्टडी आहे तो आपल्याला कशामुळे मिळतो हीट बॅलन्स शीटने मिळू शकतो. ओके. आता पुढचा कुठला लॉस दिलाय का आपल्याला त्यांनी न्यूमेरिकल मध्ये एनीबडी
Heat loss due to unburned fuel.
ओके तेवढाच दिलाय बाकी कुठला दिला नाही. दोनच लॉस दिले आपल्याला 5-6 मार्काला एवढे साधे 2-3 लॉस असतात. हीट लॉस्ट ड्यू टू unburned fuel. unburned fuel ह्याला आपण आता Q2 म्हणूया इथं कारण आपलं सिक्वेन्स Q2 आहे. व्हॉट इज फॉर्म्युला फॉर दिस कोण सांगते फॉर्म्युला MF हा काय MF1 डिवाइड बाय MF इंटू CV काय 1
CV1.
CV1. ओके. आता ह्याचं फॉर्म्युला कॅल्क्युलेट करू आपण. Q3 इथं जागा तुम्हाला कमी असल्या मी इकडे येतोय. अदरवाईज तुम्हाला जागा असेल तर वही जर आडवी केली असेल तुम्ही लँडस्केप तर तुम्ही करू शकता. ओके. MF1 डिवाइड बाय MF इंटू CV1. ओके. काय येईल आता उत्तर MF1 किती आहे कोण सांगते MF1 किती दिलाय? टोटल एका तासामध्ये किती अनबर्न फ्युएल गोळा झालंय? 16 kg. आणि टोटल फ्युएल किती आहे आपलं आवरमध्ये तोडलेलं 200 म्हणजे MF ओके 16 डिवाइड बाय 200 ओके इनटू आणि कॅलॉरिफिक व्हॅल्यू किती आहे त्या फ्युएलची अनबर्न फ्युएलची 37 किती 80 करेक्ट ना? राईट 3780 आणि ह्याची व्हॅल्यू किती येईल? करेक्ट एनीबडी? हां
करेक्ट सर.
ओके ह्याची व्हॅल्यू उत्तर किती येते सुहास?
302.4.
302.4. अगेन आन्सर इज व्हॉट? इथं CV ह्याच्यामध्ये असल्यामुळं कॅलॉरिफिक व्हॅल्यू किलो मध्ये असल्यामुळे पण इथे उत्तर येणार किलो जूल पर केज. ओके 302.4 MF1 डिवाइड बाय MF इंटू CV1 16 डिवाइड बाय 200 इंटू 3780 and answer is given 302.4. हाँ हाँ दिली मॅडम दिली. एक मिनट ठेवतो. हाँ 30.2 302. किलो जूल पर केजी आपण इथे दिल्यामुळे इथे द्यायची गरज नाही. आता पुढचा लॉस कुठला दिला त्यांनी पण सांग. ह्याचं युटिलायझेशन किती येते? ह्याचं युटिलायझेशन Q2 डिवाइड बाय QS इंटू 100. आन्सर how much answer? Anybody? 1.1. श्वास बाकीचे करताय का नाही? 1.10. ओके आणि फोर्थ लॉस कुठला आहे? आता मला जागा नाही म्हणून मी फक्त डायरेक्ट फॉर्म्युला लिहितो. लिहा तुम्ही. फोर्थ लॉस इज व्हॉट? काय असतो फोर्थ लॉस? रेडिएशन. ओके heat loss due to radiation. You write down heat loss due to radiation. ह्याचं काय येणार उत्तर लास्टला? Q काय Q3 इज इक्वल टू QS इकडचा QS मायनस इन ब्रॅकेट Q युटिलाइज्ड फॉर जेवढी लागते तेवढी स्टीम Q प्लस Q1 प्लस Q2. And what is value? Anybody? इथे काय आता कॅल्क्युलेशन करायची गरज नाही. Q3 म्हणजे 27,300 वजा इन ब्रॅकेटमध्ये 17,300 सॉरी 19,320.72 अधिक 5,414.9 अधिक 302.4. हाऊ मच इट इज कमिंग? इथले तुम्ही हा इथले येतो ही 2260 कोणी झाले 84. इथं 2260.4 2261.98. ठीक आहे. सुवास झाले 2261.61. ओके आता इथं आणि ह्याचं युटिलायझेशन किती येते? 8.28. 8.28. ओके 2260.4 त्या वहीमध्ये आहे ते माझ्याकडे आहे. ओके आणि आता सगळे लॉस संपले. अजून कुठल्या लॉस बद्दल माहिती दिली का? नाही. रेडिएशन झालं म्हणजे आपण सगळे लॉस कॅल्क्युलेट केले. जेवढी माहिती त्यांनी लॉसची दिली आपल्याला न्यूमेरिकलमध्ये त्या बॉयलरच्या ट्रायलमध्ये, ऑल इन्फॉर्मेशन वी हॅव कॅल्क्युलेटेड. एनी अदर इन्फॉर्मेशन इज गिवन नाही. आता टोटल काय करायची, टोटल करायची आणि वी हॅव टू गो फॉर आन्सर. सो नाव आय विल गो फॉर that notebook answer. Okay. तर हे असे पद्धतीनं what we have to do is, so given data is there, still we have to write given data. MS 1520 kg per hour, temperature of feed water 30 degrees Celsius, X is equal to 9.95, pressure 8.5 bar, MF calorific value of coal, CV coal, MF 1 16 kg, CV of ash means CV1. Okay, mg 70 upon mf, mg upon m directly I have given 17.3, tg 330, cpg 1, ta 17. Like that, though whatever is given is our nomenclature we have to go for. Still we have calculated the efficiency, me into bracket hs minus hw. Okay, then eta boiler, m is me into this formula she has used. Okay, 7.6 into hs minus hw divided by 27300, and we are getting hs is equal to hf plus x hfg, hf at 8.5 bar, hf at 4 bar plus hf at 6 divided by 2. हे वर्गात असताना नीट लिहून देता येतं तुम्हाला. ओके, hf at 5 8.5 bar 732.05 किलोजूल पर kg, hfg at 1 bar, दोघांचा एव्हरेज काढायचा, hfg चा काढलाय आपण. hs will be coming as 2668.05. okay, then hf at 30 125.7 आणि efficiency 70.77. हीट युटिलायझेशन आपण इथं काढले आपण 19,321.86. हीट कॅरीड बाय ड्राय फ्लेव गॅसेस आपण जे कॅल्क्युलेशन केली तिथं फक्त ते 5414.9 आणि त्याचं पर्सेंटेशन पण ती काढून ठेवलं, जेणेकरून आपण टेबल भरताना सोपं जावं. सगळ्या व्हॅल्यूचे कॅल्क्युलेशन झाल्यानंतर टेबल भरल्यानंतर सोपं जाते. हीट लॉस ड्यू टू अनबर्न फ्युएल, MF1 डिवाइड बाय MF इंटू CV1, 16 डिवाइड बाय 300, त्याप्रमाणे व्हॅल्यू आपण काढलेली आहे. रेडिएशन एवढा. आता इथे टेबलमध्ये व्हॅल्यू भरलेली आहेत. याची बेरीज टोटल 2730 येते, याची पण बेरीज 2730 येते का? 27,300 येते,
येते सर.
येते. जरी आली थोडी फरक पडला तर काय करायचं, एक्झॅक्ट लिहिताना लिहायचं, तेवढंच लिहायचं 27,300 आणि पर्सेंट युटिलायझेशन किती, 100. एव्हरीबडी अंडरस्टँड दिस न्यूमेरिकल. आता फक्त मी न्यूमेरिकल तुम्हाला देतो आणि काय करतो, अटेंडन्स घेतो, कारण डाटा जरा जास्त जातोय आमच्या गौरवचा. आपण जरा इथून पुढे काळजी घेऊ. गौरव, विल टेक केअर.
येस सर.
ओके, काय मला कळाल तर कळवा काय करावं लागतं व्हिडिओ मध्ये सेटिंग. ओके, पुढचं न्यूमेरिकल घ्या. हे न्यूमेरिकल सगळ्यांनी लिहून ठेवा आणि होमवर्क करा ह्याचा थोडा. हेच न्यूमेरिकल आहे. तर फॉलोइंग डाटा सगळेजण लिहिताय की नाही, अभ्यास सोडवत आहे. फॉलोइंग डाटा वेर ऑब्टेन ड्युरिंग अ बॉयलर ट्रायल. फीड वॉटर सप्लाय 660 kg per hour, temperature of feed water, टीम प्रेशर 20 bar, टीम टेम्परेचर 350. म्हणजे कसली स्टीम आहे रे, कोण सांगते? ते प्रेशर दिले, टेम्परेचर दिले, आणि स्टीम कसली असणार?
सुपरहिटेड.
स्टीम कसली असणार? सुपर हिटेड. करेक्ट. सुपर हिटेड. करेक्ट. गुड. सुपर हिटेड स्टीम, कोल युरिड, सीव्ही कोल, अनबर्न कोल, तेच आहे फक्त. आता इथे मात्र स्टीम कशी आहे, सुपर हिटेड. त्यामुळे HS घेताना H सूपचा घ्यायचा. किती प्रेशरला? 20 आणि 25ला. बाकी सगळी प्रोसिजर काय आहे, सेम. ओके, मग ड्रॉ बॉयलर शीट अँड हीट बॅलन्स शीट सगळ्यांनी लिहा न्यूमेरिकल. आणि पुढच्या वेळेस मला हे न्यूमेरिकल बऱ्यापैकी लोकांनी सोडवलेलं असलं पाहिजे, आणि त्याची PDF तुम्ही प्रेझेंट, कोणीतरी प्रेझेंट करायची. मी कोणालाही सांगणार PDF प्रेझेंट करा म्हणून तुमची, किंवा असं वहीमध्ये एखादं न्यूमेरिकल घ्या, ते स्कॅन करा आणि दॅट यू आस्क टू मी टू प्रेझेंट. ओके, नाऊ आय विल गो quickly. I will go for the attendance. Okay, roll number 1 to 10. Unmute.
Roll number 1 present.
Okay, good. 1 present. 2 absent. 3 absent. 4 absent. 5 absent. 6 absent. 7 absent. 8 absent. 9 absent. 10 absent.
11
11.
present.
Okay, 11 to 20.
Present.
Unmute. Okay, 11 was present. 12, 13,
13 present, sir.
13 present. Okay, okay. 14,
Present, sir.
14 present. 15, 16, 17, 18.
18 present, sir.
Okay, 18
Present.
present. Okay, 18 present. 19, 19, 20, 21 to 30. Unmute.
22.
21, 21 absent. 22 present. 23, 24, 25, 26, 27, 28, 29, 30 present. 31,
30 present.
30 present. 31, 32, 33, 34 present. 35,
34 present, sir.
35, yes, sir.
34 present. 35 present. 36, 37,
37.
okay, 38,
37, sir.
38, 39, 40,
40 present.
okay, 40 present. 41, 41 to
41
50,
present.
41 present. 42,
42 present, sir.
43, 44,
44 present, sir.
okay, 45, 45, 46, 47,
Sir, 47.
okay, 48, 47 present.
47.
48, 48,
48 present, sir.
okay, 48 present. 49, 50 to 50, 51 to 60. Unmute. 51, 51, 52,
53
53,
present.
54,
53 present.
okay, 53, 55, 56, 57 present. 58,
Yes, sir. 58 present. 59, sir.
59 present. 60, 61,
Yes, sir. Present 16.
62, 63, 64, 64, 65, 66, 67.
Yes, sir. 67, sir.
Okay. 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77. ठीक है. Okay, we can leave.
19, sir, 19.
19. Okay, I have taken 19. Okay, 19.
Sir, 58. 58.
58.
48,
I have taken.
sir.
48 also present. Okay. We'll meet next lecture. Until that, you have to solve the numerical.